Hi everyone, take a look at quiz 3. On the whole, pretty well done, so that was good, pretty high average. You can look on Canvas, of course, for your score compared to the average, etc. Okay, now first one, it was from the periodic trends packet. A couple of you kind of didn't see that was cesium, not carbon, that's cesium, right? So be careful there. Okay, so we're looking at sodium, oxygen, cesium, and nitrogen, and we're going to put them in order of, and there's 3, of course, right? So increasing atomic radius first, right? Now remember the trick, kind of draw like a mini kind of periodic table map, right? That's the trick, yeah? And then all trends in the periodic table are diagonal, yeah? And it's the question of, well, which side, bottom left or top right is big, which one is small? Well, obviously the biggest atom in the periodic table is on the bottom, and it's on the left, okay? So cesium, and it's kind of where they fall on that diagonal. So cesium, sodium, nitrogen, oxygen. Okay, and that's what I taught you in class, right? So hopefully you got that one. A couple of people got the order switched. Increasing means small to large. So smallest first is kind of the reverse trend, isn't it, right? So be careful, right? So that's the largest, that's the smallest. Increasing radius, smallest first. Okay. On the other test, of course, I just changed the word from increasing to decreasing. It was the reverse trend. So cesium, sodium, nitrogen, oxygen. Okay. Next one. Now this was kind of a special case, okay? So ionization, right? First ionization energy, how much energy it costs to remove an electron. Yeah, okay. It's going to be small down here because metals, you know, they easily make plus ions, right? And high up here because oxygen is an electron stealer, essentially, right? Highly electronegative, big first ionization. So let me just rephrase that, okay? So first ionization, the ability to remove an electron, right? Metals like to give away electrons to go plus, whereas non-metals like to gain them to go minus. So it's kind of harder to get them out of the non-metals, right? So like most trends, apart from radius, yeah, the small number is here, the big number is up here, okay? So increasing means small first, so first, second. Now be careful, right? You may have written nitrogen and oxygen. That would be incorrect because there's a special case for nitrogen and oxygen. If you missed it, go back and check the video because it's a subtle feature of the nitrogen and oxygen electronic structure, okay? It's called half-shell stability, okay? So that's actually switched. That's one of the exceptions you've got to look out for, okay? So that's actually switched in terms of the diagonal order for a special reason. Other one, I just changed that word again, so it's the reverse order, okay? Last one, decreasing electronegativity. So getting smaller, right? So high, low, it's a true diagonal trend, right? Okay, so decreasing is the largest, and I run backwards, okay? So it's that same order as up here, okay? So increasing radius is the same as decreasing electronegativity because they're actually switched in terms of bottom left is small or big, right? So it's the same trend if you switch the word. That makes sense. The other one, obviously just change the word again, so it's the reverse number, reverse trend. Okay, all right. So that's the first one. On the whole, that was pretty well done. Okay, if you thought, oh, I'll just look up the numbers online, I knew, because what I teach you in class is one version of this, and there are kind of contradictory stories online. Okay, so if you try to look up the numbers, I know, so don't do that. All right, it does say not to look stuff up. All right, now. Next one, complete the following table. Assume each atom has, a regular and non-expanded, octet. So basically, what you're thinking about is the Lewis and the dot diagrams as relating to the periodic table, which I showed you in the notes. Okay, so if we do look in the periodic table, helium obviously is element number 2, 2 electrons, 2 protons, so 2. Only has one shell, so 2 valence electrons. How many unpaired electrons, right? So you remember the number of unpaired electrons is the valency, how many bonds it makes. Well, they're paired, right? So no, it doesn't make bonds. That's why it's an inert gas. It's in the last column. Yeah, cool. Carbon, element number 6, 6 electrons, 2 on the inside, 4 on the outside, so 4 valence electrons. They're all unpaired, so 4 bonds is made. Okay. Nitrogen, bit of an interesting one. Element number 7, right? So there's 7 electrons total, 2 on the inside, 5 on the outside, so 5 valence. And then, hey, there's a pair and 3 singles, so it makes 3 bonds, right? Okay. Now the other one, change it up just a little bit. So neon element number 10, okay, has a 2 and then an H structure. So the outside layer is by definition the valence layer. So well, one or two people put 0 here for number of valence electrons. Well, it's 8. It's just that they're all paired because they're, you know, inert, right? Doesn't make any bonds because again they're all paired, no unpaired. Okay. Oxygen element number 8, 8 electrons, 2, right, and then 6. So 6 on the outside, 2 pairs, 2 singles makes 2 bonds. Fluorine element number 9, 2 on the inside, 7 on the outside, 1 of which is unpaired. Okay, nice and easy. Okay, so any questions? Feel free to post in the the comments in water cooler chat or right here. And on the whole, pretty good. So good stuff. See you next time.